IVT. Intermediate value theorem, guys. We're just going to take a quick peek at this dog to understand what it means. It's almost a no duck. Like you see it and you're like, well, why do we have to call it a theorem? Isn't that obvious? All right, so polynomial functions, there's something special about them. Polynomial functions are continuous, which means on their graph they do not have something like this where they have a gap. This doesn't happen with polynomial functions. In fact, polynomial functions don't do this either. Okay, they don't have a hole. They don't have a gap. They don't have asymptotes. They do not do this. Whatever. I can't even think of a graph that does that. Okay, but they don't have an asymptote. Okay, they have to have a value for everything. They are continuous. So like I'm going to put C in for each of these. In this, like if this was C. So if you were to ask to find f of C and all of these are f, it would be does not exist because it is not continuous. But polynomial functions are continuous and curvy. Now if they're continuous and curvy, you know what that means? That means this. If you don't know what the function looks like, let's say you got this x there and this x there, and you get a point there and you get a point there. If you don't know what the function looks like, this y value, not this one or this one. This would be f of a, and this y value would be f of b. But this one right here, this y value, which notice it's between this guy and this guy, this y value exists. That's what IVT says. And it's kind of obvious. It's like, what? Why do you have to say that? Because, so like the function is going to go like this, in which case it exists right there. Or it's going to go like this, in which case it exists right there, there, and there. Or it can go like way down here and then up, but then it still exists right here. So see, no matter what, this value right here exists. We'll call this f of c. So there is a c somewhere between a and b that exists. That's what intermediate value theorem says. That's it. And so you get problems that say stuff like this. They go, all right, guys, you got this function. It's f, right? And it's continuous. It's a polynomial function. If you're on this interval from 2 to 3, is there an x-intercept between 2 and 3?
Yeah.
And you're like, I don't know. Like, I don't know what f looks like. And so what you have to do is you have to take the f. Actually, here, let's actually put an f. All right, like let's define it somewhere. Let's say that f of x equals something crazy, like x to the 5th plus 10x squared minus 3x plus 2. Okay, I have no idea what this thing looks like. Okay, but I want to know between these two numbers, does it have an x-intercept? So this is what you do. You go f of 2 and you find that, and you go f of 3 and you find that. You have to find each of these values. So let's do that. Let's go 2 to the 5th plus 10 2 to the 2nd minus 3 times 2 plus 2. What do I get? What is 2 to the 5th? 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. Oh, wow, I should just listen to you. And then we got 40, then we got minus 6, and then we have a plus 2, right? Right? Yes. Okay, so what? Did I do something wrong? No, good. Okay, what's my answer? It's 72 right here. No. And then minus 6 would be 66, and then plus 2 would be 68. So I get 68. That is what f of 2 is. What is f of 3? Let's plug that guy in. Oh, this one's going to be gnarlier. So we have 3 to the 5th power plus 10 times 3 to the 2nd power minus 3 times 3 plus 2. So what is 3 to the 5th? That's 3 times 3 times 3 times 3. I know is 81, right? What is 81 times 3? Oh, that's a big number.
No, it's 27 minus 9.
Not Doug. Well, 3 times 3 is 9, times 3 is 27, times 27 times 3 is 81.
Which is 243.
And then 81 times 3 is 243. So 243, can you guys check that math with the calculator? Okay, then we have 90 minus 9 plus 2. Okay, now I'm pretty sure I'm going to get a positive number here. Don't you guys agree? Okay, so I get a positive number for the 2, and I'm going to get a positive number for the 3. Do we know by the intermediate value theorem that there exists an x-intercept between 2 and 3? Yes. We don't. We don't know. What would have to be true about one of these numbers if x-intercept existed between 2 and 3? One of them would have to be negative. Like let's say for example, if we plugged in 2, we got a negative, and then in 3 we got a positive. Now, do we know that there's an x-intercept there? Yes. So if f of x wasn't defined by this, but it was defined by something that gave us a negative number and a positive number, we can say yes by the intermediate value theorem. And that's it. That's the intermediate value theorem. Works for any continuous function. So if you know that the function is continuous, has no holes, no asymptotes, anything like that, no gaps, then you know that the intermediate value theorem will work for it. You can prove that numbers exist. Okay? Like I just gave you an example like, okay, prove that there is an x-intercept between 2 and 3. I could say, prove that there is a 60, a y value of 60 between 2 and 3. And if this is what you got, then you're like, oh, well, look at this one. It's below 60, and this one's above 60. That means there exists a number between these two that will give you 60. Right? That's by the intermediate value theorem. That's all it says. Here's it looking official and stuff. Here's the intermediate value theorem. Let A and B be real numbers such that one is less than the other. If f is a polynomial function such that f of A and f of B don't equal, then in this interval, that's important that they don't equal. F takes on every value between f of A and f of B. That's what I said with you guys. Remember? I drew this. Oh, well, I drew like the same picture. That's crazy.